the last topic. All right, we have to start now. We actually have to. We're on the camera. We're on the clock. The last topic is going to be on something called aromatic, and it's really a whole separate branch of organic chemistry. All right, now up till now we've done, and you should be pretty good at naming straight chain compounds, even if they got double bonds in them, and even cyclo compounds. And this kind of looks like one too. All right, it kind of looks like what? What would you call this? It was a cyclo compound. Cyclohexane, right? And you see, well, it's got these double bonds in it, though, if you look carefully. And it's not cyclohexane, because cyclohexane, if you remember, had the chair in the bow conformation and had two hydrogens coming off of each of these carbons. It's because we have these alternating double bonds, if you look at it, if you can see them, and that we actually don't have cyclohexane. There's a whole, believe it or not, a whole branch of chemistry called aromatic chemistry that's devoted to just this guy and all of the things that he can make. There's a lot. You can put different stuff on them. You can join them together, and it's called aromatic chemistry, and that's what we're going to talk about today. All right, look at that crazy guy. I mean, the weird part about it, he's much weirder than he looks. He looks like he's just like a double bond here, double bond there, double bond there. I can name him as 1, 3, 5. Cyclohexatriene. All right, but that's we call him. We have a special name for him. He's called benzene. Okay, they're all derivatives of benzene. Everything that we're going to talk about in aromatic compounds are derivatives of what we call derivatives of benzene. They have benzene in there somewhere. And they may have something else added on to them. They may have more than one benzene ring. And there's a lot of compounds that have the benzene ring in them. A lot of compounds in your body. A lot of hormones and steroids that have benzene rings in them. Benzene itself is a carcinogen. We don't use it. I used to have, when I first came here, there were bottles of toluene and benzene and all these aromatic compounds, which you shouldn't have in a high school lab. There's really no reason for it because they're very flammable as well, and they're also carcinogenic. What does that mean? Carcinogenic.
They can cause cancer.
Cause cancer, right. All right, so aromatic compounds are derivatives of benzene. And basically what you can see there, they have 6 bonds, but what you don't see is that they're all identical. Say, no, they're not. I've got a double bond, then a single bond, then a double bond, then a single bond. No, not really. This is the weird thing about benzene. That is not an accurate representation of what benzene really looks like. If I were to be, and don't ask me how, because honest to God, I don't know how, but if you were to measure somehow or other the strength and the length of each of these bonds, you would not find that I've got a double bond here and a single bond there. You would find they're all exactly the same, because these electrons are allowed to kind of move around, and they actually what's called hybridize. You know what hybrid means in biology? What do they mean?
Combination too.
Right, a combination or a cross. And so instead of being this guy, or I can move this double bond over to here, they don't really flip back and forth, although we kind of show it that way in what's called a resonance structure. They actually are just one bond. It's kind of partly a double bond and partly a single bond. It's a very weird guy. All right? No single structure is going to represent this guy. No single structure is going to do it. God bless you. That's good. By the way, another shortened way I could write this guy would be like that. And if I don't have him drawn there, I don't think I do. Draw him to the side. Oh, I do have one below, but that's what I want to show you in a second anyway. You can draw him to the side. This is just a shortened way to do it. You know, we already have seen a lot of drawings like this with using beaker. We've had, instead of drawing a carbon in every one of these with the correct number of hydrogens around it, we just drew lines. Well, that's the stick figure for benzene, and that makes sense. That's how you probably would have drawn it. Believe it or not, beaker would actually name this guy as well. He's pretty good. But the thing is, no one structure actually represents these guys. So we often draw them as what are called resonance structures, and I want to show you that in a second. Resonance structures. All right. Just write the word resonance structure. But I have the picture of the resonance structure in your thing. Now, this is not your picture, but it's the same basic thing. You look here for a second. Don't write. Just watch. See, notice in this one, the double bond's here, and here there's a single bond, and neither one of them is real. And so, you know, it's kind of like every one of them is partly a double and partly a single. So what you often will find, well, first of all, in reality, it doesn't flip between the two. It actually is just one bond. It's got the characteristics of both a double and a single bond. Each one of them is exactly the same.
Is that what these dashes are? Is that where you want us to write that?
Yeah.
Like, is there another dash?
Yeah.
I think those two below the first picture are from the first one.
It doesn't really matter.
Yeah, I was thinking that too.
And it doesn't really matter because all of this is about benzene anyway.
That picture isn't.
I know it's not the same picture, but your picture is the same thing. Look at where the double bonds are in your picture as well. See, there's alternating between one or the other. See, in one case they're down here, and the other one there's a single bond there. Same thing's true for yours. I just found better pictures online since I made those notes up. Okay. Now the electrons, instead of actually being here or here, double here and single there, are actually what we call delocalized over the entire ring. And I actually draw that a certain way, okay, as you write that down. It's drawn a lot of times like that, as a circle. And you have that drawn on there too, right? See down below there? Your next one down? We draw it as a circle in the middle, showing that there's not really a double or an alternating double and single bond, but rather the electrons are kind of delocalized over the entire ring. And I actually have another little description of that on that other paper I gave you. After you're done writing that, look at this paper, this one here, okay? Look at that paper, and it's got a little description of what's going on there. You can read about that, all right? It kind of looks like a donut at the bottom. Get this one out. Look at that one right now at the bottom. And it kind of looks like a donut. Instead of having those bonds, double or single, you actually have them like a ring almost over the entire, and that's why it's drawn like that with a ring in the center. So you could draw benzene a number of ways. I could draw them like this. I could draw them like that. Sometimes I could even draw them like I had before, I believe. You know, you can draw them like that. Okay, all of those are representations of benzene. Okay, any one of them you could use. Now, I want to teach you how to name. Getting into the resonance structures, and we'll talk about that a little bit more when we get to the next chapter. I don't want to talk about resonance structures too much right now. Just basically know that the electrons aren't limited to, when they have a double bond next to a single bond, the electrons kind of are able to move. All right, they're not limited to being just between these two carbons, especially if they're equal on either side. And what you'll find is that that doesn't just happen in benzene. It happens anywhere there's a double bond. But I don't want to get too crazy with you on that right now, because that is a pretty weird concept. We'll talk about that a little bit later, not in this chapter. All right, let's talk about how we name these guys. That's what I want to talk about for this chapter. That's what we're concerned with. How do we name benzene and his derivatives? Because there's a lot of neat little things that happen with benzene. We have special names. This is the thing. When you get to college, you're not going to see. Matter of fact, even the bottles that I buy sometimes don't have the UPAC name on it, the IUPAC name that you've been getting from Beaker for a lot of compounds. For example, I'll never buy a bottle of ethanoic acid. I'll buy acetic acid or vinegar, basically. It's a 5% solution of acetic acid. All right, it's just, there's a lot of things like that. Ethyl alcohol you'll buy. It'll say that on the bottle, and that's how most people call it, even though technically it's called ethanol. And there's a lot of things that are like that. And I will, and really it starts with benzene derivatives. A lot of them have special names that we use. They're special names, like I said about a minute ago. Toluene is one of them. All right, so these guys are named pretty much the same way, same rules you would have used to do your, do you have this paper here?
No.
I have no idea what.
You're just really throwing me for a loop right now.
This
Okay.
is bad notes.
These are bad. These are bad. It's okay.
I have no third.
They're named the same way. Just put that anywhere because I have examples down below that. You see it? It's named the same way. You would name alkanes. You give the substitution groups lowest possible numbers. And benzene is the parent or the longest chain. Right? That's what you would normally do. Find the longest carbon chain. Well, the longest carbon chain is going to be benzene when we have these guys. And we'll have a chlorine on there. You'll see I have an example down below on your thing of what is called chlorobenzene. See it there? Again, I have slightly different pictures than yours, but they're the same thing. Notice how yours is drawn. I want you to draw this one like this right next to your picture of chlorobenzene, because you could draw it a number of ways. Your picture was drawn this way. I'm going to erase this in a second, but your picture was drawn like this, which is also just as legitimate. As a matter of fact, it would be just as legitimate to draw it like this. Does it matter where that chlorine goes? No, because wherever he goes, he's going to always be numbered as the lowest number possible. And the reason he doesn't even have a number here is because if you only have one thing, you assume it's a 1 anyway. Now, if I have more than one, we're going to see what we do there. All right? So you can draw that guy any way you want to, any way of the ways I've already shown you. Okay? That's with a ring instead of with this and a chlorine on it. I could draw, actually drawing out the carbons. Okay, and put the chlorine on it, and my hydrogen's coming off of these. I mean, there's a lot of ways you can draw it, but you don't need to draw it all those different ways. I'm just showing you it can exist. You may see it in the book drawn all those different ways, so that when you do see it, you don't say, oh, well, I never saw that before. Yes, you did. The guy down below him is methylbenzene. Now, you have it directly below him. I have it to the side. I'm going to erase it here. Okay? Methylbenzene, no surprise, I'm sure. You know what that's going to look like. It's right there on there. What's another way I could draw methylbenzene? Well, there, like that. That's what methylbenzene is. That's another way. You have it drawn a different way down there. You have the actual molecules on it, right? But that's the same thing. There's methylbenzene right there. You see it? Okay? So draw this guy like that on there. So you have more than one way you're seeing these guys. Now, by the way, the fancy name or the common name for methylbenzene is toluene. All right. Again, I would probably not order from a chemical catalog methylbenzene. Most of the time, if you get a bottle, it's going to say toluene on it. All right. There's a lot of things that are like that in chemistry. You just don't use the actual systematic name for the chemical. So you kind of have. There's not many that I make you know. There's a few of them. Acetic acid is one of them. All right. You're going to have to know that one when we get to it. Ethyl alcohol and some of the other ones, amyl alcohol, because we'll be using them in ester labs. But in this chapter, and this is the last day of this chapter, the only ones you're going to have to know the common names for are going to be toluene, which is methylbenzene, and dimethylbenzene. Let's look at dimethylbenzene. That's an interesting. If I think about dimethylbenzene, you already have the paper there. There are, first of all, its common name is xylene. Is that written on their paper for you?
Yeah.
Okay. First of all, there are 3 different isomers of this guy. And if you think about it, there's only 3. Because if I try to move them around in different places, let's see what happens. This is a good structural isomer debate here, okay? Where you're going to have questions like this in the future. They're already drawn for you, right, or no?
Right.
All right, look at it. You might say to yourself, okay, well, why I moved him here, I moved him there, I moved him there. Well, isn't this guy a different one too? If I move him over here?
No.
Yeah, why is this guy not different from the other ones? Because all I've done is I've made this guy again, right? Okay? No matter what, well, all right, what about this? That's not up there, is it? Sure it is. Yeah, it's the last one. It's this one over here. Now, they all have special names, too. Okay? And this is really where you're going to see some prefixes you may have seen other places before. All right? Not like in common language. This guy right here, well, I have them all up there. He will be his systematic name. Do I have the systematic names on there?
No.
Okay, write those on underneath. Obviously, 1,2-dimethylbenzene, 1,3-dimethyl, and 1,4. That shouldn't surprise anybody. You always give them the lowest possible names. So that's not really a big surprise. But they have other names too. And they are written there above you, right? And you've probably seen some of those. Okay? Where they're called ortho, meta, and para. And if you look at some of your, I used to do at this point, actually it was not at this chapter, but at the end of the next chapter, when we start talking about the other, right now all we've done so far have really been alkanes, alkenes, cyclo, and these. You realize there's about 10 more that we're going to cover. We're going to talk about alcohols, alkynes, oh, we did alkynes, alcohols, esters, all these different compounds, you don't even know what they are. And what I would do for an extra credit project, which I don't do anymore because with the advent of the internet over the past 10 years, it's been too easy to get the answers. I would have you guys go home and any household product that you could write the formula for, given its name, and it was in there, you'd bring me the label then, all right? You would get points for like every so many of those that you did, bonus points. But I don't do that anymore because at this point, you could basically take any label, type it into the computer, on an internet search, and it will give you the formula. I wanted you to use your own knowledge to do it. You know what I'm saying? And you'll see if you look at a shampoo bottle, all right, or if you look at hand lotion. Somebody has some, right? You have the hand sanitizer. You will see these prefixes all the time: ortho, meta, and para. All right, and you're gonna I'm telling you have to know that to use your hand lotion, but you're gonna have to know those prefixes for the organic because they often indicate the position of groups on a ring. All right, ortho is when the two things are next to each other, meta in between, and para are opposite each other. Okay, and actually I have a very famous compound I'm going to pass around as a little demo in a minute that you may have all smelled before. Two of them actually. All right. So if I were going to name, do I have an example down there below that one?
No.
No. Let's do an extra example then. I'm going to do this guy. I'm going to pass around for you. All right. This is what you're going to be smelling in a second. Okay, copy that and name him. Name him two ways. Name him the systematic way, and name him based on the using ortho, meta, and para. First of all, the systematic way, using numbers and the way we would have done it before. What would you call him? 1,4 dichloro. Don't forget the dichlorobenzene. Exactly. Okay. That's exactly what's in here. What's his common name? What would the prefix name be? Para-dichlorobenzene. Para-dichlorobenzene. And you actually are familiar with para-dichlorobenzene. No. That xylene is only for dimethylbenzene. It's only for dimethylbenzene. Okay. Good point, though. I should have really mentioned that. Look at these xylenes on here. Xylene means dimethylbenzene. That's what it means. So 1,2-dimethylbenzene is orthoxylene. Xylene does not apply to dimethylfluorines or chlorines or anything else. This, I want you to smell as I pass it around. Go ahead. It doesn't smell horrible, but you can smell it, and it should smell familiar. What does it smell like?
Mothballs.
Well, no, it doesn't. Mothballs are different. They're coming around later in a few minutes. What does that smell like? What? Yeah, you can smell them already because I brought them out. But smell this. Yeah, ew is right. Exactly, right. It smells like a porta potty. It smells like those urinal cakes they use in. Guys probably smell this more often than girls, I would imagine. What's that? Yeah, root beer. Oh, actually, that's what they did. The girls have this in their labs now. The guys have all these flavored.
Yeah.
Does it have to be flavored?
Well, I don't know if they're really flavored, but they're scented. Yeah.
You don't eat it. We don't have it.
Yeah, you guys don't have those, but guys do, and they have all these new flavors. But that's the common one. You probably all. You know what it smells like? It smells like the fair bathrooms. That's what it smells like. The fair bathrooms. Yeah, isn't that fun?
It smells like a clean porta potty.
It smells like a clean porta potty.
No, it smells
When you
like
walk
this,
in, you
like,
know it's
like,
good, you're happy about that. You like to smell that.
All right.
I'm not touching.
Why do I have it so you can smell it? That's why I have it. And I have my own little urinal back there, just in case I have to go. Actually, I should because I leave enough time to do that. All right.
Yeah, I know, but like I have them.
Okay. Now I have one more thing to show you here, as you can see down below. You can not only do you have stuff on these rings, but you can have rings that are fused together. Okay? And some examples of that, fused ring structures, all right, would be naphthalene, which I'm going to pass around. Naphthalene is your classic mothball smell. I'll pass this one around while you're copying these. That one should smell like your grandmother. Why? Because they're old, and when you become old, you start smelling like mothballs.
That really does smell like my grandparents.
Thank you.
Old fashioned.
The reason is, yeah, because your grandparents probably use mothballs to store their clothes in. So their clothes, and you may even still, and your clothes end up picking up that smell. But we don't use them much anymore because nowadays girls like wear an outfit once and then throw it in the garbage. What's that?
I never knew what that smell was.
Isn't that a great smell?
No.
Yeah,
It is. It's like it's a Grammy smell. It's a Grammy smell.
No, I don't like that.
Abby likes that smell.
I like it.
Thank you.
I keep those in my glasses.
It's an old-fashioned smell. So look, draw this guy, or is he already drawn for you on there? He's already drawn for you on there.
I think.
He doesn't have to circle.
You don't have to put C10HAE,
Wait,
whatever.
on our paper.
Yeah, again, it does, now Danny said, and I believe Allie's asking. Look it. Does it matter that I drew it like this or that I drew it the way on the paper? No.
No, but there's only one line. Like, if you drew it with the lines together like that.
Yeah, it is. I would just. It is only one line. Yes, they're sharing this bond. They're sharing this guy right here.
So I wanted to know.
Yeah. Did you all get that? Put it back. Thank you. All right. So you can actually have fused. And some of these guys, man, they get so big they look like chicken wire. I mean, you get a whole bunch of these guys up here, and they just keep growing. If you look on. Nobody uses it anymore because everything's basically computerized. But those big books up there I have, the CRCs. They're the Chemical Rubber Company's Handbook of Chemistry and Physics. In the, when we did labs, you had to look up every compound you use during that lab and write its structure and formula and all the properties of it. And if you look up in that book, there's just page after page after page of aromatic compounds. Because if I just keep growing this, I mean, they can keep growing. Like anthracene, for example, is the next logical step. All right, if I had 3 of them together. So you can see, by the way, kind of coming full circle this last day of class here, you can see why we have an entire branch of chemistry called organic chemistry. Not only do the straight chains straight carbons form like chains that could be like, hundreds of carbons long. But then you can have ring structures can do the same thing. I mean, you're talking about an entire branch within a branch of chemistry, aromatic chemistry, aromatic compounds. And that guy's called anthracene. If you look at many of your, like I said, cortisone, many of the testosterone, estrogen, they will have benzene rings or parts of them as part of their structure. They're in your bodies right now. Now, benzene itself, and this guy right here, is also a carcinogen. Benzene, or the actual derivatives of it, many of the different things we use all the time. And you can, obviously, mothballs. I wouldn't eat them, but they're not going to kill you by smelling them, obviously.
But do you think you'd die if you ate one?
I don't know. I think you'd probably be poisoned.